Okay, so we're looking at homework from section 5.1. This is question number 17. Let's go ahead and read the question. You work for a consumer watchdog publication and are testing the advertising claims of a tire manufacturer. The manufacturer claims that the lifespans of the tires are normally distributed with a mean of 40,000 miles and a standard deviation of 7,500 miles. You test 16 tires and get the following lifespans. Complete parts A through C. So we have 16 different lifespans given. Draw a frequency histogram to display the data. Use 5 classes. So that's the first thing we need to do. How are we going to do that? Well, first, we have to find the class width. And hopefully you remember from chapter 2, the class width formula. Class width is max minus min divided by the number of classes. And then we always round up to the next whole number. So the maximum value here is going to be 47,596. The minimum value is 23,392. And we divide by 5, which is the number of classes we were told to use. When we do that subtraction, we get 24,204 divided by 5. Dividing, we get 4,840.8, and we have to round up to the next highest whole number, which is 4,841. That's our class width. Once we have the class width, we can form our frequency distribution. So we have to set up our classes first. To set up our very first class, we start at the minimum data value. So our first class starts at 23,392. To get the next lower class limit, we add the 4841 to the 23,392, and that gives us 28,233. Remember that when you add the class width, you're getting the next lower class limit, not the next upper class limit. So we add 4841 again and get 33,074. We add 4841 again and again. Once we have all of our lower class limits, then we can work with the upper class limits. And the first upper class limit is 1 less than the second lower class limit. So because the second lower class limit is 28,233, the first upper class limit must be 28,232. Then we add the 4841 to that number, and we get 33,073. Add 4841 again, and again, and again. So those are our 5 classes. Now we need to go entry by entry to decide where those entries, where those data values belong in these classes. So 47,596 is in the last class, so I'll make a little mark. 39087 belongs right here. 23,442 in the first class. 34,291 goes in the third class. 31,215 goes in the second class. 40,590 goes in the fourth class. 39,385 goes in the fourth class. 37,164 goes in the third class. 23,392 goes in the first class. 29,252 goes in the second class. 37,601 goes in the third class. 36,625 goes in the third class. 31,005 goes in the second class. 33,641 goes in the third class. 37,698 also goes in the third class. And 43,435 goes in the last class. So that's our last data value, so we can go ahead and tally up our frequencies. The frequency of the first class is 2, then 3, then 6, then 3, then 2. So looking at that, what kind of a distribution would that be? Because it's asking us to draw a frequency histogram. Well, this frequency histogram is going to be very symmetric, 2, 3, 6, 3, 2. Right? It's got the same numbers at the beginning and end, same numbers for the second and fourth, and the number in the middle, and the highest bar is in the middle. And it descends to the left and right of that highest bar. So this one looks a whole lot like it could be a bell curve. So let's see what our options look like. These are the graphs that we have to choose from. So remember, it was 2, 3, 6, 3, 2, and that would be choice B. That's the histogram that matches that description. So, is it reasonable to assume that the lifespans are normally distributed, and why? Well, we said it looks very much like a bell curve, and bell curves would be normally distributed graphs. So this is reasonable to assume that it looks like a normally distributed graph. So my answer here is going to be yes, because the histogram is symmetric and bell-shaped. So that is part A. For part B, we're supposed to find the mean of the sample and find the standard deviation of the sample, rounding to 1 decimal place. So to find the mean, we need to add up all the data values and divide by the total number of data values present, which in this case is 16. So I'm going to add the first 8, and when I add those first 8, I get 292,770. Then I'll add the second 8, and I get 272,649. Adding these together, we end up with 565,419. Now to find the mean, we're going to add these data values up and divide by the total. So that's 565,419 divided by 16, which is 35,338.6875. But we're supposed to round to 1 decimal place, so this is 35,338.7. Now what about our standard deviation? Well, we could make a table like we had in the notes for section 2.4, but it's probably going to be better for us if we use the calculator to help us. So how do we do that? Well, the first thing we're going to do is press the Stat button, and that's going to take us to a screen that looks like this. And we're going to immediately hit Enter, which takes us to our list screen. Now on this list screen, what we need to do is we need to enter each of the 16 values in L1. So all 16 of those tire lives we're going to enter in L1, and when we're all finished it should look something like this. Once we've got those entered, we're going to hit Second and then the Mode button. What that does is that takes us back to our home screen, our blank home screen, because we're always supposed to kind of go back to the home screen after we've finished entering a list like this. Then what we're going to do is press the Stat button, and that takes us back to that original stat screen that we were on, but this time we're going to press the right arrow key. And when we press the right arrow key, that moves the top menu from being Edit over to being Calc. You'll notice that the one variable stats line is already highlighted, so we press Enter. Pressing Enter is going to put the one variable stats command on your home screen. Pressing Enter again will give you all those one variable stats. It gives you the mean, which we already found by hand, several other values, Sx and sigma x. Those are both standard deviations. Because this is a sample, we're going to use Sx. So our sample standard deviation here is 6,585.48534, rounded to 1 decimal place, is 6585.5. So let's review what we got for our mean and our standard deviation. The mean was 35,338.7. and the standard deviation was 6585.5. Now, both of those values are less than the manufacturer's claims. The manufacturer claimed that the average life was 40,000 with a standard deviation of 7,500. So we can answer our next question here, which is compare the mean and standard deviation of your sample with those in the manufacturer's claim. Discuss the differences. Choose the correct answer below. So when we read through these, we're looking for which statement says that both the mean and the standard deviation were less than the claimed. And that would be choice C. The sample mean is less than the claimed mean, so on average the tires in the sample lasted for a shorter time. The sample standard deviation is less than the claimed standard deviation, so the tires in the sample had a smaller variation in lifespan. And that's your answer.